In this question, we are given R1 and R2 are equivalence relations in a set A. And what we need to show here that R1 intersection R2 is also an equivalence relation here. Now, what we can do, let's say that there is an element A that belongs to the set A. Now, since R1 and R2, here R1 and R2 are given what? It is an equivalence relation. So we can say that AA belongs to R1 since it is an equivalence relation, and it's R2 is also an equivalence relation. That means AA will also belongs to R2. Now look into this. If I find the intersection of these two, what you'll say that its intersection is what? AA. So you'll say AA belongs to R1 intersection R2. That's how we can say therefore R1 intersection R2 is reflexive. This is reflexive. Now coming to the next, we have to prove that R1 intersection R2. But we know that R1 and R2 are symmetric. That's given. That means we have been given, let's say, if I start with let A comma B belongs to R1 intersection R2, right? Then we need to prove here. We need to prove if you prove that B comma A also belongs to R1 and R2, that means we prove that R1 intersection R2 is symmetric. Now, first of all, since AB belongs to R1 intersection R2, it means what? If AB is present in the intersection of two sets, that means AB is present in R1, right? And this AB must also be present in the set R2. Now, if AB is present in set R1, I can say that means I can say that BA also belongs to R1. And if AB belongs to R2, since R1 is what? R1 is reflexive. Sorry, R1 is given symmetric. We already know that here that R1 and R2 are equivalence relation. That means if AB belongs to R1, then BA also will belongs to R1 because this is reflexive. R1 is reflexive. And since R2 is also reflexive, that means AB belongs to R2 implies what? BA also belongs to R2. Now check here. If I tell you that BA belongs to R1 and BA belongs to R2 as well, and if I ask you what is the intersection of these two, you'll definitely say that BA will belong to the intersection of R1 and R2. So we'll say therefore, hence R1, R2 is what? R1 intersection R2 is symmetric. Now coming to the next, that is transitivity. So now here we are going to take let say AB. You have to start with a let statement. Let AB BC that belongs to R1 intersection R2, right? So it means what? It means if AB BC is present in the intersection of R1 R2, it must be present in R1, and this BC must also be present in R2. If it is present in the intersection, that it means it must be present in both R1 and the set R2. Now check here, if AB belongs to R1 and no, I think we should first deal with R1. Since it is AB BC is found in the intersection of R1 R2, it means AB belongs to R1 and BC also belongs to R1. Now, since we are given that this R1 and R2, once again, R1 and R2 are what? Equivalence relation. So it must be transitive as well, right? So if R1 is transitive, since R1 is transitive, then I can say that, AC belongs to R1, and the reason is R1 is transitive. R1 is given transitive. Now, similarly, the same way we can do with this other one, that is AB from here. From here, AB and AB belongs to R2. Is it AB? No, AB is dealt with. Now we'll come to, yeah, that's right. AB belongs to R2 and BC also belongs to R2. And how did I say? From here, since AB, BC belongs to R1 and in the intersection of R1, R2. Now check here, if AB belongs to R2 and BC belongs to R2, and we know that R2 is transitive. Therefore, from here we can say that AC belongs to R2. As you know that R2 is transitive. Why? Because we are given here in the set that R1 and R2 are equivalence relation. Now, what we can conclude here that since R1 and R2 are transitive, what we can say that AC also belongs to R1 intersection R2. Now, what once again, you can see from here that, let me change the color. Oh, that will be fine. From here, what you see that from here, AC belongs to R1 and AC belongs to R2 implies what? AC belongs to R1 as well as R2. Now, one more time, we started with this. We started with this, that AB, BC belongs to R1, R2, right? And we proved that AC also belongs to R1, R2. That means we can say that it is intersection, R1 intersection R2 is transitive. So we proved here R1, R2 transitive. We proved here R1, R2, R1 intersection R2 is symmetric. And over here we proved that R1 intersection R2 is reflexive. Therefore, we'll say that R1 intersection R2 is an equivalence relation.